This lesson is on exponent properties. When dealing with exponents, we have a few situations we need to figure out. First one is when we have two things with the same base and an exponent a or b. They could be the same exponent or different exponents. When we've got the same base, in this case x and x, when we're multiplying the exponents, when we're multiplying these terms, we can add the exponents together. So we end up with this situation where we've got the same base. If you notice, we've got x's all around, but for my solution, or my simplified answer, I have x to the a plus b. What I did was I added a and b together. As an example, we could have x to the 2 times x to the 5 equaling x to the 7. Okay? Instead of multiplying the exponents together to get x to the 10, when we're multiplying these terms, we get x to the 7. The next property is called the quotient property, the previous one being the product property. What we've got going on here is we've got x to the a divided by x to the b. So they've got the same base. What we do with the exponents is we subtract them. So we'll end up with x to the a minus b. As an example, we could have x to the 6 over x to the 3, giving us x to the 3, okay, where we subtracted these exponents. If we would have divided them, we would have gotten x to the 2, which wouldn't have been the right thing. The next example is when we have a power to a power. When we've got x to the a to the power of b, what we actually do this time is now we multiply the exponents. So we've got x to the a times b. As an example, if we have x to the 4 times, or to the power of 3, we get x to the power of 12. Let's give you guys another example. X to the 3 times y to the 5th to the power of 4 over 2x squared times y to the 6th to the power of 3. Now in this case we're going to combine several steps in one. You'll notice that on top we've got x to the 3 times y to the 5 to the power of 4. So we've got the power rule going on there where we've got a power to a power. On the bottom we've also got the same thing. And eventually, because we're dividing, we're going to need to subtract powers as well. Now to figure out the top, we need to distribute that exponent into both exponents on the inside of the parentheses. And on the bottom we do the same thing where we're distributing that 3 into the exponents and also into the number at the beginning. So we end up with x to the power of 12, y to the power of 20, because of the 3 times 4, and then y to the 20 because of the 4 to the 4 times 5. On the bottom, we end up with 8 because of 2 to the 3. We end up with x to the 6 because of 3 times 2, and we end up with y to the 18th because of 3 times 6. Now we need to deal with the division. Here we end up with x to the 6, y to the 2, because we've got, for our 8, there's no other number on top that we're dividing by, so we'll just leave the 8 down there. We've also got x to the 6 because we've got 12 minus 6 gives us x to the 6. Since our power is positive, we're going to leave it on top. Y to the 20 over y to the 18 gives us y squared. Again, since the power is positive, we leave it on top. If we would have had a negative power, let's say we would have had a situation where we're doing this. We've got x to the 3 over x to the 8. In this situation, we've got 3 minus 8 when we're subtracting those exponents. So we would end up with x to the negative 5. Whenever we have a negative exponent, we change that to become 1 over x to the 5. So if we have a negative exponent up here, we move it down to the denominator. If we have a situation where we have a problem like this, where we've got 1 over x to the negative 5, the negative exponent is on the bottom, that negative exponent makes us switch it to the top, so it'll become this. Okay? So whenever we've got a negative exponent, we just switch it. If it's on top, we move it to the bottom. If it's on the bottom, we move it to the top, and we change the exponent to positive. And that should be it for the basic exponent properties.